Wednesday episode, the current one, and that. It's called Behind the Drawing, where we thought we could get 4 faculty members up here who have sort of worked through some sort of drawing type that has been innovative to them, or a project that has come out of a particular need to represent something or design something that that needed a new kind of drawing convention. So the goal for today is to have 4 different presentations that'll all last 10 minutes each. And the idea is that they're going to be a kind of conflation of kind of conceptual ideas, problem solving, and kind of technical information download, so that it's somewhere between a tutorial and a just kind of getting in the thought process of what produced a particular drawing. So the 4 people who are here today are all quite different in the types of drawings that they make and use them very differently. So we hope that it will provide a kind of wide range of tips, techniques, and ways of thinking through representation and drawing making in various guises. So thanks for coming. And we have a informal order just to kind of keep things organized. It's going to be Andy, Sean, Sarah, and Jim, Jimenez. All right, so they're going to have to bring up their own computers because they're going to be using their own programs, so there might be a little bit of a lag between to just kind of get through the technology of projectors warming up and things like that. So please bear with us as we shift between people. But first up is Andrew Mosley.
All right, so I think when thinking about our work in my office, we tend to focus on large-scale projects and landscapes, and it's other than the on-the-ground, eye-level perspective of what it feels like to be in a place. All of the we do for many different types of spaces, whether architectural or landscape or urban design. We have really worked a lot on developing these aerial obliques pulled out of Google Earth as a way of communicating. It's kind of the big image that you can show someone and they get the project in one image. So again, you could show someone plan, drawing, and plan sections, eye-level perspective, but we always try to do one signature oblique. This is a 300-acre airport, so to have someone understand the design idea behind the whole 300-acre site in one image, we've spent a lot of time and put a lot of hours into this type of drawing. So I'm going to go through just kind of what goes into one of these and some of the thoughts behind that. So I just pulled up a couple examples at the beginning. So this is an airport in Caracas. This is a 50-acre waterfront in Helsinki, and this is still just kind of a Google perspective, but then we build in information and at such a level of detail that you can print this really high resolution and still understand everything that's there, but also back out and understand the whole project. And so the one I'll go through is this drawing here for a 13-acre park in Denver that we worked on in collaboration with another professor, Paul Anderson, here at the school. So, and again, it's very low-tech and starting out. So this is literally just opening Google Earth and selecting the perspective that we're going to build on. And so that's the first step of selecting an underlay. So again, we're not building everything from scratch. We're not doing it just in the 3D model, but we'll find our site from Google Earth, and it's not very pretty, and sometimes it's rough, but in the end, it doesn't end up mattering. And then another important part is for us, at least, to build these up, is there's a lot of front-end Rhino work and a lot of renderings pulled out of Rhino while thinking through how we need to build up a drawing like this. It typically has, about 1,000 layers and takes about 30 hours. We want to make sure we think through how we're going to build it up, so there's a lot of renderings. So just to begin with, this is the design of the project, so that has to be worked out. This isn't the drawing where this is a final representation drawing, not one where we're developing the project through it necessarily, but just as a final means of communication. So I just isolated some of these layers on the side, and I'll just kind of quickly go through how we build up an image like this. If you have any questions, let me know. This isn't necessarily mind-blowing information here. I think it's more just about thinking about how you build up the many layers in a drawing like this and what it needs to say. And then also, I think everyone's going to convey the fact that this just takes a really, really long time, and you want to think about each of the pieces. So anyway, there's a base render, and that just has, we isolate out everything we want to see and turn off drawings. So if we turn off the site, it's just those pieces. We never render out a complete scene and rely on rendering software for that, but just render out a very basic underlay of the project that we can then put over Google Earth. We also render a bunch of helpers at the beginning. So we turn on these. These are just masked layers of what the design will look like in the site. And so they're just dumb colors, so we can go to Photoshop, select color range, and grab everything at once, and it just allows us to work a lot more quickly. We also isolate all the trees on the site so that we know when we put all the trees back in Photoshop that they're the right height. And then we also put in scale figures. As you can see, we just distribute people all over the site, so anytime we place a person in the scene. And I should mention that this drawing was built for a public project to be conveyed to the public and for them to understand the project through one image and public presentation. So that's also weighs in pretty heavily into the audience and how it's communicated, or what we're trying to convey in this drawing. So we have render base stuff, and then we also go through and we render all the shadows and isolate all those by themselves, and then render each of these pieces by themselves. So it just gives us a lot of control of turning all of the elements on and off. And so those are all the things that we would render out on the computer, and the rest all happens in Photoshop. So using, again, this color mask, if you turn on the color mask, select something, and then apply it back over the other stuff. So when it comes to the base materials, we'll isolate all those things, run through the materials on the ground. So, and that includes the base grass. And we always put in every layer in the drawing twice. So the first layer would be, if you look up here where it says normal and opacity 70, we'll find grass or whatever it needs to be. We need to size it to the right scale. I think the biggest mistake people make in these drawings and other drawings is having things that are so far out of scale that they interrupt a clear reading of the project. So you end up with like 6 foot tall blades of grass. It sounds like common sense, but you have to really make sure that the images that you're sampling are appropriate to scale and place them. But we always put in one layer, usually like 70% opacity with normal, and then the next layer, we use these a lot with the overlay and the soft light and color burn, vivid burn over the top. And we just like to put together a really oversaturated drawing. So we end up just doing, again, lots of layers and lots of burns for each thing. And so that's another thing we see too, are readings of these drawings that are very flat and don't have a whole lot of life because they're not quite, we just prefer them to be really oversaturated. So there's the grass, that's built back up. And then we came through, and there's about 230 trees on the site. So we inventory those as part of this project, but end up putting those in one by one, sizing them and putting the shadow below them, and end up building up the existing, because this is obviously an existing site. So those all end up going in. So you do get all the trees back on the site. But again, that's placing each one individually, sizing it to where it goes, dropping down a shadow. It's not if you end up with every tree looking the same or them all from the same perspective, again, it destroys, it is a different reading of the kind of flat reading. And same with the people. So I turn all this off, we put in a few hundred people, but scaled to those helpers and with shadows, and starting in the foreground with the bigger ones and copying back. So you end up with all the people and all the trees. And then also we'll do a full Illustrator plan typically of the project, just like that. And we'll bring the Illustrator drawing itself back into Photoshop. So we'll actually flatten the plan that's done in Illustrator, and that's a way of bringing in all of these textures and colors back in as well. So here we have a mowing pattern in the grass, or some of these dots and dashes around the site. Let's see, something like an area like this. So this is really just bringing in a flat 2D drawing, distort it into the scene, and then we'll burn it back down over the top. So again, using overlay or normal with 65 opacity, but we'll put everything in 3 times or so, like I was saying. So let's see, materials, renders. Time here. Okay, so then all the people, all the trees, and then one of the last few things we do is we'll take everything, flatten everything out, and then reapply the whole rendering of itself over itself 3 or 4 times too, in order to burn or wash different areas of the image. So the full scene burns. We want to concentrate, like right here, there's no hierarchy in the drawing at all. Or, this tree right here is just supporting this, or, obviously you're black and white, there's a big green middle, but we want to burn out the edges and focus the light on the center of the image. So we have a total scene burn here, and then a soft light burn where we just really pop the middle. And so again, that's using soft light and erasing much of the side of the image. And then we kind of casually refer to this as Jesus light, but we always have some Jesus light layers where we usually have some rainbow effects or something going on. There's just something different about this being on or off. I don't know. It's really important. So, that's a little bit. So anyway, we'll build up something like this, but I think that's about all I have, but it's just a lot of, again, I think it's so important to think through it, and it's a lot of using your 3D model to your advantage, a lot of Photoshop to your advantage, and then bringing a new Illustrator on top of that. There's just no substitute for a drawing that has 20 or 30 hours of work into it. It reads like, or I think it reads in a really robust way. So that's all I have. Do you have any questions?
Maybe say the question.
Okay. So that's what I have. Thanks. 9 minutes and 15 seconds.
Super dark image in the middle. I'm going to talk about that. Okay, so just to kind of give it a quick idea, a lot of the work that I'm fairly interested in has a lot to do with using various forms of material energies. I'm not going to get too much into this, but the idea of trying to think of how do you give shape and form to energy as a type of architectural space. And so to do that, I have to overcome a couple of obstacles, which is primarily how do you do this without making it look like it's completely always a rendering or completely fantastical. So just a little background about a lot of these kind of models. This is a base for the image. So even though we're going to be talking about Photoshop work that kind of goes into how you make that image itself, this is actually a combination of a physical model and a rendering. And for a lot of the work I do a little bit of both all the time. So I've always found that doing physical models allows people to buy into the project a little more easily. So if it's completely a rendering, there seems to be this sort of fantastical aspect to it. But if you can add some layer of physicality to it, then it helps make it a little bit more believable. So in making the physical model, this is actually the space, but this works in two parts for me. This is actually not only trying to make an image that I can convey an idea for, the kind of shape that the kind of project's supposed to take, but also build a mock-up of it, which I was going to try to run a kind of small-scale version of how this thing works. So what we're looking at is, this is a plaza in front of the Museum of Contemporary Art. This is in here, so you can see the side of the border. And then this is the patterning that's up front there, and then this is essentially a laser cut acrylic that actually is not just the pattern, but actually a substructure behind it as well. So there's a 6 or 9 inch piece here that actually has 3 portal entries where we're actually going to connect a compressor, an air compressor, and nozzles that actually move the air velocity through here, and a vacuum on this side that then pulls it back down. So the idea is that by actually making the physical model, I can then run this thing through. The other thing about this is I actually don't have a computer up here, so I'm actually doing screenshots, and that's basically because desktop. So I don't actually have a laptop to show you software on. I do that basically just for presentation or lectures, but I don't do any real heavy lifting on laptops. So this is the image, there's the background. I then have what you can't quite see here is there's a backdrop, a black cloth that's then used as the kind of backdrop for the image. Sometimes it's just simply the black. Sometimes it can actually be a photograph or an abstract image. But it has a lot to do with the materials, the energies that I'm using, and how they're actually going to be read. And a lot of this requires a dark background, so you can actually see that contrast between them. So this is that image. This is actually the photograph that was taken with the scale people and the lighting that's actually inside the LED lighting that's inside the massing below. So you have lighting coming from below, as well as the people that are standing on it itself. So this really starts by trying to get an understanding of what the shape is that I'm trying to convey through it, and then starting essentially creating with these air velocities. This is just a layer of air velocity, trying to build on top of it this kind of sweeping motion. So working with this kind of larger velocity of air that comes from the lower part, and then falls back down on the right-hand side to the right-hand side. So part of this is actually trying to get an idea of what the intentionality of that movement and that shape is going to be. A kind of hard edge that moves along the y-piece and then comes back a little bit smaller. I got a piece of advice when I was in school, which was when I was working in geometry and working on Maya or Rhino. And I think I mentioned this to my class, that if you're picking CDs and moving CDs when you're working in Maya or Rhino, and you're not using the larger lattice structures or the what do you call them, the larger properties that kind of are inherent to the software itself. If you find yourself picking CDs, you're going about it all wrong. So you're basically going through this and trying to pick little points here and there. The same method of thought, basically, how you sculpt shape associated with geometry, through CDs and splines and curves. I would make the same analogy in a way to when you're looking at these energy systems. So these are larger brushes that I either sample from or get online, or I mutate and bastardize it myself. But I don't go in there with a paintbrush and kind of sculpt line by line by line, because that's an easy rabbit hole to run down that just has no exit. So by doing these as discrete kind of larger moves, you can start to build a kind of larger body that has things on together. So this is all black and white. I don't use any color at this point. These are all just the white moves. And then on top of that then is an overarching gradient that goes from a fill from left to right, which I don't know if you can quite make out, but it's just going from red to green across the entire thing. And then from there, I can burn it out. This is a different color sample, but you can see the big move where you're going from a kind of bluish hue on one side to a greenish hue on the other. But by doing it across the entire image, it allows you to take a sample between, but not have to worry about painting. Similar to the idea of the geometry, where I'm not painting individual moves, but making larger brush strokes across. On top of that, then, you probably rather make out are a series of particles. So these are particles that are added to various locations between the two. Then there's particles that we get again, but this time they're stretched and pulled through a blurring motion on the right-hand side that just blurs them to kind of play against the air velocity. And then these two, or these layers, will kind of essentially lock down together with each other. Contrast is not so great as a projector, but then there's a smaller level where I start to figure out how do I want that edge to look as a condition, trying to figure out any gray moments that kind of pull out and get a little more characteristic of the edge. A little bit of what Andy was saying as well is, at this point, once the image is essentially been collected together, it's really only at this point that it all gets collapsed, flattened as to one big image, and that one large image then gets used as the final product. So on top of having a flattened moment, then going back on top of it and adding either a thin layer across all of it that may need just a 1% or 2% transparency, just to kind of lock the entire thing together. Then going back up and working with the contrasts and the shadows, just finding a way at this point where, again, you're not looking at individual pieces, but trying to lock the entire drawing together through a kind of larger filtering system. So no longer looking at it as layer by layer, piece by piece, but looking at it as a larger construction and a larger pad. That's it.
both as a sort of a way of depicting something, but also as a drawing. So as a drawing that is interested in showing sort of everything at once. And so it's not only about the thing that's on the page, but also the way that the thing relates to the page. First, I'm just going to show some outtakes of the details of it. But outtakes of the process, just so you can see that like the drawing it's not like you make something and then you do the drawing of it, but the drawing is sort of like developing the whole way through as the technique for the drawing is developing the whole way through. So this is like very early on, just looking at sort of arrangements of instruments. But as you go through, like they're starting to be drawn as wireframes. The arrangements are being changed, but also we're starting to think through how the things relate to each other, I guess, in space. And so this is just a series of outtakes. so then I said before that we were interested in the way that not only the things being depicted in the drawings relate to each other, but also the way they relate to the page, or essentially like how you understand them as both sort of two-dimensional and three-dimensional at the same time. And so there are two major techniques, two major techniques that we used to look at that. So one is the idea of sort of what you can see or what you can see through something else, or transparency. And so you can see these drawings, they are similar to wireframes, but they're not actually wireframes. So they're not about the sort of three-dimensionality of the object that is made by a wireframe, but rather sort of seeing through the objects to what else is on the page. And the other thing is the shadows. And so the shadows are drawn not relative to where the objects are in space, but rather as though all of the objects are sitting on the page. That makes sense. So that the shadows are sort of doing the job of flattening out the objects because they're not relative. So if it were relative to where the actual sort of exploded pieces were in space, they would all, like some of them would be meeting up with the objects or the parts, and some of them would be distant from them, right? Some of the parts are above in space, so the shadow would be somewhere else. So I'm going to show you just, I guess, a couple of the So when I was talking about the shadow is sort of a type of an axonometric, and so I'm just showing you here. I have a grasshopper definition to draw my shadows for me, or my axonometrics for me, but you can do this in Rhino without grasshopper. It's not such a complicated thing. But what I'm showing though is that I have multiple parts that I think are set. Instead of actually drawing the projection of the thing as a flattened object, what you can do is sort of skew or shear the object so that in, say, plan view, it'll appear as though it's an axonometric, but in fact, 3D model space is still a three-dimensional thing. So I guess I can show you using the shear. So that's just this. If you shear an object, in a particular view, it'll appear as a, this is not very good, but as an axonometric generator. That's that. So the other thing that I wanted to show you is just the sort of process for drawing these things. And so when we have all of the sort of the instruments that are exploded, there are a million pieces. One way to make the drawing would be to make a 2D of the entire thing, as all of you probably know. Turning that to a drawing that's clean and that has line weights is sort of a nightmare. Right? There's tons of lines, and so what we did for this drawing was every instrument was drawn in top view and elevation by itself. So here I have sort of the exploded trumpet. And so it's drawn by itself with line weight. Right? And this was done for every single instrument. They're drawn by themselves, and they all have their own sort of line weights. And here in this drawing, when everything is sort of existing as a whole before anything is hidden. And then the next set of drawings is to draw all of those things then, and to take everything that's sort of overlapping and make it into a hidden line. And so here these ones become hidden. And again, I'm sort of like rearranging my layers as I go on and sort of like making new layers every time that I do this drawing. So there's actually 4 steps in this, but I'm showing 3. The first one is to draw every instrument by itself. The second one, draw every instrument draw it so that the line weights, so that the layers are by line weight as opposed to by customer. So that would be this one. And then the shadows are actually drawn as axonometrics that have all of their detail and all of their lines, but they exist sort of behind the objects, and so it's just one layer of instruments called the other one. So that's it.
It's difficult for me to really kind of go through the layers since a lot of what I do is by hand. I could tell you I have a really, really large light table. Most of the magic happens there. There's a lot of printing stuff out, tracing by hand. I can tell you, since this is sort of a technical discussion, every single time I make a story, I spend about however much money it costs to buy a new set of micron. The one that runs through the quickest is the 005. The 005 microns, they go bust basically every page. I almost use a new micron. Also, in my office, I don't let anyone touch my macrons. I also kind of go nuts a little bit when people don't cap their microns. Micron would be the primary weapon of choice. You may know me as someone who does comics. Just for disclaimer, these days we're trying to do more. For example, right now, the Venice Biennale project, we're as well deploying Photoshop, I guess. The hand drawings being collapsed onto other drawing types, or being exported Rhino drawings. They will print it out, and I'll draw on top of it, for example, and scan it back in. And then we even started to render. So there are many aspects of what we do that you may know me best as stuff like this. And if you really, I have to say, I'm really pretty embarrassed with this stuff. I can't believe I published it. If you look at it, it's really just an Illustrator file. This is just a really, let's say, really heavy Illustrator file. I used to draw stuff out, cut them out in Photoshop, bring them back into Illustrator, and so on and so forth. And these are just really heavy Illustrator files. I would draw the separate individuals on pieces of paper, scan them back in, and then Photoshop them onto one image. And if you look at this stuff, I think there are tons of amateurish mistakes here and there. This is the very first one. This was the very first one that I did even started when I was in grad school. Clearly you can see the traces of Illustrator. Just a matter of managing it. And the frames, you can see the amateurish mistakes over here. It's scanned it wrong. The frames, I do go into a Rhino model. I do build a Rhino model of the frames so that it could be exact and correct. So that I can also numerically, kind of be sure the gaps are consistent. And as with what Sarah was saying, if there's lines in the Illustrator file, they're organized by line weights. They're not organized by other qualifications. So there's that. I can't really here. I'll show you one specific project that I've been working on more recently. Well, not more recently, but this year I was working on. So here's my desktop. You can see my desktop now. I will show when I grow up. When I grow up is a new story that I worked on this year. Maybe I can quickly show you what the final outcome was. That's the basic up. That's with nothing. And but where's when I grow up? When I grow up, there's a story about 3 kindergartners graduating from kindergarten, and they're asking each other, "What do you want to do when you grow up?" There's a fireman kid who wants to grow up to be a fireman, so he can jump through buildings and hang out with real firemen and save people. There's the mission control kid who has a constellation above his bed that he likes to imagine his own constellations. And then there's the Michael Jordan kid who wants to be a basketball player because he wants to be good at rules and so on and so forth. They start talking about the houses that they want to live in. This kid wants to live in a clubhouse. There's a guy who wants to live in a house inside the house, so he can scratch out the outside or the inside or everything. There's a kid who wants to live in a castle. They start arguing about whose house is bigger until they imagine all the houses together with their work and everything. And that's when they start imagining what types of futures they may have through doodling and sketching. And so that's the most recent one. And when I began, it's hard because I do, really spend a lot of time running through familiar images. I do look at what real kindergarten used to look like. And I also even go into, I guess, the types of research that it's difficult for me to just draw things from thin air. And so I would just kind of start looking at stuff that I like looking at. Oh, this guy's coming to town. He's in town already. The stuff that I like, that I look at. Stuff that I want to reference as I draw it. It may not be very clear that I'm referencing it. Or things that I'm just really unfamiliar with, like basketball courts. I have no idea what goes on. So I have to do the research. But the research is not the most important part. I would say, I guess, we also even start building Rhino files of what these spaces could look like, and we often eventually don't.